All right, let's talk about one of the biggest, most fundamental ideas in all of science, gravity. And this isn't just about apples falling from trees. This is a fascinating story about how science really works, told through two of the greatest minds who ever lived. So let's just get right to it, right? The classic showdown, Newton versus Einstein. Who actually got it right? Who's the winner? Well, as you're about to see, asking who was right might just be the wrong question entirely. And that brings us to maybe the most important idea for our entire discussion today. This quote, it gets to the absolute heart of what science is all about. It's not this grand search for some final capital T truth. It's about building and improving models, these powerful tools that help us make sense of the world. So, what do we even mean by a scientific model? Well, think of it like a lens or a set of rules for a game. It's a way of explaining things that works incredibly well, actually, but only as long as certain conditions, certain assumptions are in place. And understanding those assumptions, that is the key to everything. Okay, so with that in mind, let's jump into our first model from the legend himself, Sir Isaac Newton. The best way to think about his idea of gravity is as a fantastic, incredibly practical map. This is the gravity we all learned in school. And it just makes sense, doesn't it? You've got this invisible force, kind of like a cosmic rope, that's pulling objects toward each other. Simple, elegant, and you know what? It's unbelievably powerful. Now, this is where it gets really interesting. For Newton's model to work, a few things have to be taken for granted. He had to assume that space is this flat, unchanging background, that time ticks along at the exact same rate for everybody no matter what, and that pull of gravity, it happens instantly across the entire universe. Zap. And let's be clear, this model is an absolute workhorse. I mean, engineers use Newton's laws every single day to build our world. Bridges, cars, you name it. It's simple and it just works for almost everything. But, and it's a big but, it's got its limits. It never explains why gravity happens. And when you get to really extreme situations, like near a black hole, the model just breaks. It even introduces tiny errors into our GPS system. And this is the perfect analogy. Think about it. A street map of a city is essential for getting from point A to point B, but it doesn't show you the subway lines underneath, or the fact that the city is on a curved planet. Newton gave us the perfect street map for gravity. Okay, so if Newton gave us the map, what happens when we start exploring the actual territory? Well, that's where Albert Einstein comes in. He didn't just draw a better map, he revealed a whole new landscape. Now, get ready, because this is a total mind-bender. Einstein said, forget the invisible rope. Gravity isn't a force at all. What's really happening is that huge objects, like the sun, are literally bending and warping the very fabric of space and time around them. So planets aren't being pulled, they're just rolling along the curves. And his assumptions were totally different from Newton's. First off, space and time, they're not separate things. They're woven together into this four-dimensional fabric he called space-time. And it's mass and energy that tell space-time how to curve. And the big one? There's a universal speed limit, the speed of light. So gravity's effects aren't instant, they travel. The power of this idea is just staggering. Einstein's model predicted black holes before we'd ever seen one. It's the reason the GPS on your phone works so flawlessly. But all that power comes with a price. The math is ridiculously complicated. I mean, using it to figure out how a baseball flies is like using a supercomputer to do basic addition. It's total overkill. And that really gets to the heart of the trade-off, doesn't it? Einstein gives us a deeper, more accurate picture of reality, for sure. But Newton gives us a tool that's so much easier to pick up and use for 99% of the problems we face every day. So this brings us right to the main event, the map versus the territory. And the point isn't to see which one wins, it's to understand why we have both and when we need to choose the right one for the job. Which brings us right back to that first question we asked. All right, lay it on me. Newton or Einstein? Who was right? Which model is the correct one? Turns out that's the wrong question. Asking which one is correct totally messes the beauty of how science actually moves forward. And this is the big reveal. This is so cool. Newton is not wrong. His model is actually what you get from Einstein's super complex equations when you're dealing with things that are moving relatively slow and aren't crazy massive. So Einstein's theory contains Newton's. It's not about replacement, it's about context.
This table just lays it all out so perfectly. I mean, look, do you need an easy-to-use tool to design a building? You grab Newton. Are you a physicist trying to figure out what's happening at the edge of a black hole? Well, you better break out Einstein. It's all about what you're trying to do.
So, where does all this leave us? It leaves us with a much more powerful way to think. And not just about physics, but about, well, about everything. This right here, this is the golden rule. This is the sentence to take away from this whole thing. It shifts your thinking from just memorizing facts to actually thinking like a scientist. The right question isn't, is it true? The right question is it useful? Right here, right now. And this gives us a kind of roadmap for learning. You start with the simpler model, with Newton. That builds your confidence, your intuition. Then you move on to the more complex one, to Einstein, and that sparks your curiosity. But real wisdom, that comes when you understand the assumptions behind both models, and you know exactly when to use each one. So I'm going to leave you with this final thought. This whole idea of maps and territories, it applies everywhere. In your career, in your relationships, in how you see the world. So ask yourself, where in your life are you relying on a simple, comfortable map, when what you really need to do is explore the messy, complicated, but much more real territory?